Myself, Dr. Paradesi, Department of Chemistry from SRM IST. I am going to explain about the estimation of hardness by EDTA method. Okay. So, hardness, as we all know, hardness is mainly due to the presence of calcium and magnesium salt. Okay. Water which does not form readily lathered with soap, then it is said to be hard water. Hard water cannot be used for industrial applications such as boiler and pipes due to the corrosion behavior. Okay. So, based on the type of dissolved salts like calcium and magnesium, hardness can be classified into temporary hardness and permanent hardness. Okay. Temporary hardness is mainly due to the presence of bicarbonates of calcium and magnesium. Okay. So, bicarbonates of calcium and magnesium. It can be easily removed by boiling. So, if you just boil the water, so the salts present in the water can be easily precipitated as CaCO3 plus H2O plus CO2. So, temporary hardness can be easily removed by boiling. Okay, it is mainly due to the presence of bicarbonate of calcium and magnesium. Okay. Whereas permanent hardness, it is mainly due to the presence of chlorides and sulfates of calcium and magnesium. So, CaCl2, CaSO4 twice, so MgCl2, MgSO4 twice, like. So, this permanent hardness cannot be removed by boiling. However, it can be removed by other process like soda lime process or zeolite process. Okay. So, the hardness can be estimated by different methods such as gravimetric analysis, complexometric titration and atomic absorption technique. Okay. Among these methods, the EDTA method is the most inexpensive way to detect hardness. Okay. So, EDTA is nothing but ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid. CH2COOH, 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 CH2COOH. So, ethylene diamine tetraacetic acid. Okay. So, as it is the EDTA cannot be used for titration, since it is insoluble in water, sodium salt of EDTA is used for the titration. Okay. Now let us see the principle. So definition, types. Now let us see the principle. There are two steps involved in the principle behind this estimation of hardness. So step 1, hardness causing substances like calcium and magnesium can be represented as M. Okay, forms an unstable wine red colored complex. I am repeating. Hardness causing substances like like calcium and magnesium, it is represented as M, forming an unstable wine red colored complex when reacts with eriochrome black tea, it is the azodite, eriochrome black tea, in presence of a buffer, okay, ammonium buffer. So, pH to be maintained at 9 to 10. So, this is step 1. And the step 2, this solution MEDT is titrated against EDTA. Forms a stable complex, that is MEDTA. Forms a stable complex. And it releases EDT. So, this EDT at pH 9 to 10 exhibits blue color, steel blue color. So, this is the end point for this hardness experiment. So, wine red to steel blue is the end point. Okay. I am repeating the principle. The first step, the metal ions present in the water sample, that is calcium Ca2 plus and Mg2 plus, forms an unstable wine red colored complex when treated with eriochrome black tea in presence of ammonical buffer, ammonical buffer at pH 9 to 10. So it forms an unstable wine red color complex. Okay. So the addition of EDTA, when it is titrated against EDTA, what happened? The uncomplexed metal ions, that is free metal ions. So the free metal ions make complex, makes a stable complex, MEDTA complex. Okay. So what happened? So the free metal ions form EDTA, reacts with EDTA to form a stable complex. Okay. This stable complex is colorless. This stable complex is colorless. When all the free metal ions are completely complexed with the EDTA, then further addition of EDTA removes EBT from this complex. So EBT is set free now. So that EBT at the pH 9 to 10, EBT at the pH 9 to 10 displays steel blue in color. So for hardness estimation, we are getting the color changes wine red to steel blue. Okay. Now let us see the procedure. So procedure is very simple. So first we have to pipette out. So for the determination of, in order to determine the total hardness, temporary hardness and permanent hardness, we have to conduct 3 different sets of titrations. Okay. So titration 1, standardization of EDTA, titration 2, estimation of total hardness, titration 3, determination of permanent hardness. Okay. So for all the 3 sets of titration, the Burette solution is same, that is EDTA. For all the 3 titrations, the Burette solution is same, EDTA. And the reagents are also same, ammonical buffer, the buffer and areochrome black tea indicators. Okay. And the pipette solution. So for the standardization of EDTA, we have to measure, we have to prepare that calcium carbonate solution, because the hardness is always expressed in terms of calcium carbonate equivalent. Okay, so that here pipette solution is calcium carbonate solution. Here for total hardness, the pipette solution is sample water, that is test solution. Okay. Here for permanent hardness, the pipette solution is boiled water. Why boiled water? Because it's a permanent hardness. Permanent hardness means the sample should not contain any temporary hardness. So that how can we remove the temporary hardness? As you know, if you boil the water, automatically the bicarbonate will be precipitated as calcium carbonate. Okay, calcium carbonate is easily precipitated, so we can remove the calcium carbonate by the way of filtration. So now the solution is free from temporary hardness. Okay. So that boiled water is used for permanent hardness measurement. Okay. Now, how to perform the titration? Very simple. First, you have to take a clean conical flask, pipette out 20 ml of the sample. Now, I am explaining only the determination of total hardness. So, all the 3 set of titrations, the same procedure should be followed. Okay. So, first pipette out 20 ml of the sample water and add 5 ml of ammonical buffer and add 2 to 3 drops of areochrome black tea indicator. Okay. So after adding areochrome black tea indicator, immediately the solution turns into wine red color. Immediately it turns into wine red color. Okay, because of the formation of a complex. Right. Now titrate this solution against EDTA. What happens? All the metal ions make a stable complex with EDTA. Okay. So the end point will be wine red to steel blue. So after getting the steel blue, you should measure the titer value. Repeat the experiment up to getting concordant value. So what is meant by concordant value? Adjacent value should be same. So the adjacent titer value should be same, that is concordant value. So we have to measure the concordant value, and then the same procedure is carried out for all the 3 sets of titration. Then we have to do the calculation. So calculation is very simple. First, here standardization of EDTA. So How to prepare the calcium carbonate solution? 1 gram. Suppose we are taking 1 gram of calcium carbonate in 1 liter of water. So I am writing reversely. So 1000 ml of water. 1000 ml of water in 1000 water contains 1000 milligram of calcium carbonate. So same sentence. 1000 ml of water contains 1000 milligram of calcium carbonate. Okay. So how much quantity have we put around? 20 ml. So now 20 ml of, this is hot water. Okay. 20 ml of standard hot water. 20 ml of standard hot water is equal to 20 milligram of calcium carbonate. So after performing the titration, you are getting the titer value. So the titer value is represented as V1 ml. The titer value is represented as V1 ml of EDTA. V1 ml of EDTA. So V1 ml of EDTA, V1 ml of EDTA is equal to how much quantity? 20 milligram of calcium carbonate. So V1 titer value is corresponded to 20 milligram of calcium carbonate equivalent. Therefore, 1 ml of EDTA is equal to 20 by V1 milligram of calcium carbonate. So now the EDTA is standardized. That means we know 1 ml of EDTA is required to get the titer value of 20 by V1 milligram of calcium carbonate. Okay, right. Now let us see the total hardness calculation. So here, what is the titer value you are getting? V2 ml. V2 ml of EDTA. So V2 ml of EDTA means 20 ml of sample water. 20 ml of sample water is equal to V2 ml of EDTA. V2 ml of EDTA. So I am writing V2 into 1 ml of EDTA. V2 into 1 ml of EDTA. We already know 1 ml of EDTA is equal to 20 by V1 milligram of calcium carbonate. So apply this value here. V2 into 20 by V1. 20 by V1 milligram of calcium carbonate. So this value corresponds to 20 ml of sample water. Now we have to calculate 1000 ml of sample water. So 1000 ml of sample water means 1000 into V2 by V1 milligram of calcium carbonate. That's all. We know 20 ml value. From this we can easily calculate 1000 ml of sample water. So it is equal to 1000 into V2 by V1 milligram of calcium carbonate. So this value represents the total hardness. Now, boiled water titration. Same. So titer value is represented as V3 ml of EDTA. Okay. So 20 ml of boiled water. 20 ml of boiled water is equal to V3 ml of EDTA, or we can write V3 into 1 ml of EDTA. 1 ml of EDTA. So 1 ml of EDTA already we know the value, 20 by V1 milligram of calcium carbonate. So V3 into 20 by V1 milligram of calcium carbonate equivalent. So this value corresponds to 20 ml. So from this we can easily calculate 1000 ml. Why 1000 ml? Always the hardness should be expressed in terms of ppm or milligram per liter. So 1000 into V3 by V1 milligram of calcium carbonate equivalent. So from this we can easily calculate the permanent hardness. From this we can get the total hardness. So we know total hardness and we know permanent hardness. Then we can get temporary hardness. So total hardness is equal to temporary hardness plus permanent hardness. Therefore, temporary hardness is equal to total hardness minus permanent hardness. So by directly we can get the total hardness from this titration, and directly we can get the permanent hardness by using boiled water titration. So from these two values we can easily calculate the temporary hardness.